All right, so we're going to take a look at competition 2 from 2014-2015, and we're going to do all 6 problems. So here's the first one. Ron and Peyton mow lawns in the summer. Ron has a riding lawnmower, charges $20 per yard, and pays his brother $10 to help. He can do 9 yards in a day. Peyton has a walking mower. He charges $22 per yard and does 8 yards in a day. What is the positive difference between how much Peyton makes a day and how much Ron makes a day? So if I'm doing 9 yards at $20 per yard, that would be $180. But he doesn't get to keep that because he pays $10 to help. Now, this competition has a bunch of vague problems. Now, is that $10 to help per yard or $10 to help total? Does it make sense that someone would get paid $10 for the day? No, probably not. So it's safe to assume that it's $10 per yard to help. So that's $90 for the help for a total of $90 for Ron. His brother charges $22 per yard, and he does 8 yards in a day. So you multiply it out. And what is the positive difference between these two? Well, it's $86. So moving on to the next problem. Matt plans to visit the cities of Chicago, San Francisco, Orlando, and New York in one vacation. How many different ways can he plan his vacation if he's only going to visit each city once? So he has Chicago, San Fran, Orlando, New York. So for his first city, how many different places can he go? Well, he can go a grand total of 4 different places. For his second city, he can go 3 different places because he's already been at 1. For the 4th city, he only has 2 options, and then the last city is pretty much chosen for him because he's not repeating. And so, since those are the total number of options, you multiply them together, and you get a grand total of 24 different ways he can schedule his vacation. All right. There are 2 prime numbers between 100 and 199, such that the tens digit is a prime and the ones digit is a prime, and the tens and the ones taken together in either order are prime. And so, what are the prime numbers? Well, 2, 1 is neither prime nor composite. 3, 5, and 7. And so I can pretty much cross these out because I know that if I have, even if I have 23, I have to be able to reverse the numbers and get a prime number, and anything that ends in a 2 other than 2 is going to be not a prime number. And so I know that 73 and 37 are both prime, and 137 and 73 are both prime, and so we want the sum of them. So you add them together, carry the 1, so you get 310. For number 4, a committee including 3 boys and 3 girls is to be formed of a group of 10 boys and 10 girls. How many different committees can be formed from the group? Now the interesting thing is we need to break this up. We know that we have 3 boys and that we're going to have 3 girls. Well, for the boys, we have 10 to choose from. Order does not matter in this point, so it is a combination. And so we have a combination of 10 boys, 3 boys that we can take out 10 people. For the girls, same idea, but we have 12 to choose from. So here's the deal. For So we need to find the combinations here, and quite frankly, I used my calculator, my graphing calculator, to do that. But for those who don't remember or don't have a graphing calculator, a combination, to find it, you'd have n factorial over quantity n minus r factorial divided by r factorial. So we have 10 factorial over 7 factorial over 3 factorial, which is going to be equal to 10 times 9 times 8 times 7 factorial over 7 factorial times 3 factorial, but 3 factorial is 3 times 2. So the 7 factorials cancel. 2 goes into 8 4 times, 9 goes into 3 times, or 3 goes into 9 3 times, and so we have 12 times 100. 12 times 100 is, so you have 120 options for the boys. For the girls, same basic idea. So we're going to have 12 factorial over 9 factorial times 3 factorial, which is equal to 12 times 11 times 10 times 9 factorial divided by 9 factorial. 3 factorial is again 3 and 2. So these cancel out. 6 goes into 12 twice, and so we have 20 times 11, or let's do 22 times 10. 22 times 10 is 220, and so you multiply these two bad boys together, and so you get an answer of. Now the part in this one that would be confusing is, why do you multiply these two together? Well, for every one combination of the girls, you could have 120 different combinations for the boys. So for the 220 combinations for the girls, you would have, for each one of those, you'd have 120 variations of it dealing with the boys, and so that's why you multiply it together. All right. Last two. 50 metal spheres with a radius of 1 centimeter are melted, and they're melted, and the melted is filled into a rectangular cylinder. This has got to be a rectangular prism because it gives you dimensions for a rectangle.
Sorry. Can I borrow a calculator?
At this point, I'm going to need them, and class is going to switch in 2 minutes. The answer is no.
Okay.
All right. So to find the volume of a rectangular prism, we know that we're going to do base times height or base, let's do length times width times the height of the prism. We know that we have 5 times 4 times height, so we have 20 height, and that's going to be equal to the volume of these spheres. Now the volume of a cylinder can be found by 4/3 pi r to the third power. And the radius is 1, so 1 to the third power, 1 times 1 times 1, is just 1. So we know the volume of each sphere is going to be 4 pi over 3, and I have 50 of them. So this is equal to 200 pi over 3. So we know that 20h is equal to 200 pi over 3. Well, we don't really want a fraction, so I'm going to multiply both sides by 3. 3 divided by 3 cancels it out here. So I'll multiply this by 3, and I will get 60h is equal to 200 pi. And the fun thing here is it tells you to give your answer in terms of pi. So that means I do not need to multiply out 3.14. Hallelujah. So then, divide both sides by 60. And so I get h is equal to, well, let's see. What goes into, well, 10 goes into both of them, right? And so then what goes into 20 and 6? That's right, 2. So we have 10 over 3 pi. Now it doesn't matter if you have the pi in the numerator or the denominator, either one would be fine. Last problem. Two numbers are chosen at random with replacement from the set 1, 2, 3, 4. The two chosen numbers are used as numerator and denominator of a fraction. What is the probability that the fraction represents a whole number? So if I have a 1 in the numerator, what numbers would give me a whole number? Well, a 1 would a 2? No. 3? No. 4. So when I have a 1 at the numerator, I have one whole number. When I have a 2 in the numerator, I could come up with two whole numbers because I could use a 1 or a 2, but a 3 and a 4 will not give me a whole number. And I'd have a total of 4 options. Again, 4 options here. When I have 3 in the denominator, I have another 2 options because I could have a 1 or a 3. And that's 4, and I have 4 possibilities. A 2 and a 4 doesn't do anything for me there. And then for the 4, I would have 3 options because I could have a 1, whole number would be 4, or I could have a 2, whole number of 2, or I could have the 4. And I have, again, 4 total options. So 3 plus 2 plus 2 plus 1 is a grand total of 8. And I have 16 total variations. Now I can't answer like that because it needs to be reduced. So I end up with a 1/2 chance of getting a whole number. Probably not the answer you'd expect given the problem.